Welcome to today's deep dive. So, have you ever wondered why the smartest AI models in the world can write a flawless sonnet in 2 seconds, but then they just spectacularly fail at a basic multi-step engineering task?
Oh, yeah, it happens all the time. It's wild to watch.
Right. Well, the answer actually lies in something called the agent harness. It is this non-LLM engineering layer that wraps around the base model.
Yeah, and today we're unpacking why, in production, this harness actually matters way more than the model itself.
I mean, there's a whole industry mantra surfacing right now.
Yeah.
Like, if you're not the model, you're the harness.
Exactly. And to understand why the harness is so critical, you really have to look at how base models physically operate. They're inherently amnesiac by design.
Amnesiac.
Yeah. Once a context window closes, its short-term memory is just completely wiped.
Oh, wow.
So left to its own devices, a model suffers from what engineers call groundhog-day rediscovery. It just wastes all this computing power relearning its environment every single turn instead of, actually progressing on your task.
Okay, so let's unpack this. If the LLM is basically just a brain in a jar, it can't make a decision unless it knows exactly what is happening right now.
Right, it needs context.
Which implies the harness has to actively build a picture of the current state gathering past decisions and rules before it even lets the model think. But wait, isn't the model's reasoning still like the hardest part to build?
I mean, it is the most computationally expensive part, for sure. But raw intelligence is essentially useless without structural guarantees.
Makes sense.
To actually get work done, you need the agent loop. It's a strict execution cycle. So assemble context, invoke the LLM to reason, and then observe and act by using tools.
So without that structure, the brain in the jar cannot actually affect the outside world.
Exactly. And that first step, assembling context, is doing a lot of heavy lifting. It bridges those isolated amnesiac reasoning windows to prevent one-shot overreach.
One-shot overreach.
Yeah, that's where a model tries to execute a massive project in one chaotic turn. It's usually a disaster.
I can imagine.
So the harness feeds the model a persistent environment. It supplies just enough past decisions, tool outputs, and rules to get it up to speed instantly.
Which is vital for enterprise systems,
Yeah.
right? Like if one agent defines Q4 revenue differently than another, the whole system just collapses.
Right, the harness provides those governed shared definitions.
But it can't just be about context. It has to be about proof, too. I mean, if an agent writes a script, it shouldn't just assume it works based on reasoning alone.
Oh, absolutely not. The harness acts as a strict gatekeeper for verification.
How so?
Well, if the model generates code, the harness intercepts that code and executes it in a sandbox test runner or maybe a headless browser.
Okay, and if it fails?
If it fails, the harness takes that specific error log, packages it as a new prompt, and forces the model to correct its own mistake before moving on.
I see. But things in the real world break all the time. APIs time out, or a database returns bad JSON data. Right. And if the model is fundamentally amnesiac, I'd imagine a failed API call would cause it to just aggressively retry the exact same failing action.
Until it hits its token budget and crashes the system, yeah.
Yikes. So how do you fix that?
That's where bounded recovery comes in. Rather than letting the model spiral into an infinite retry loop, the harness intercepts the error and enforces a strict escalation protocol.
Okay, so it limits the number of retries.
Exactly. It limits retries, it isolates the diagnosis of the root cause from the execution, and crucially, it prevents silent, unauditable failures from just compounding into a total crash.
Wow. So if you are building, buying, or just trying to navigate enterprise AI right now, it might be time to stop obsessing over which base model is like 3% smarter on a benchmark.
Absolutely. The secret sauce is in the orchestration scaffold surrounding it. The harness is what translates a science experiment into a production-ready system.
It is the defining line between a toy and a tool.
Perfectly said.
Which leaves you with a final thought to ponder. As base models become exponentially more capable natively, like boasting massive, near-infinite memory context windows, will the need for these complex, rigid agent harnesses eventually disappear?
Or will true enterprise-grade reliability always require that external, hard-coded safety net wrapping the brain in the jar?
Something to chew on as you look at the next wave of AI.